from Group 4, and today we're going to discuss about the quadratic equation.
Let's talk about quadratic equation, topic 1. The definition of quadratic equation. Quadratic equation in one variable is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equals to 0. Given equation can be transformed into standard form. 5x plus 2x squared equals 10. But first, what is a? A is, next is b, and c. Substitute the value to the variable. The equation is now in standard form, and the equation is a quadratic equation. Now let's see if the given equations are quadratic or not. X squared minus 5x minus 5 equals to 0 is
Quadratic!
quadratic. 4x minus 4,
Not quadratic!
not quadratic. 3x squared minus 9 equals 0,
Quadratic!
quadratic. 3x squared minus 9x equals 0,
Quadratic!
quadratic. Squared equals 1,
Quadratic!
quadratic. X
Not-
minus 5 equals 0,
Not quadratic!
not quadratic. X quantity 3x squared minus 2x plus 2 quantity equals 0,
Not quadratic!
not quadratic.
So now, let's discuss the topic 1.2, which is solving quadratic equation by extracting square roots. An incomplete quadratic equation, which is ax squared plus c is equal to 0, can be solved using the square root property. If a and c are complex numbers, and if x squared is equal to c, then x is equal to square root of c, or x is equal to negative square root of c. So now, let's try solving it by giving some examples. X squared is equal to 64 is a second-degree polynomial equation or quadratic equation. So now, let's try the square root property. X squared is equal to positive negative square root of 64 is equal to positive negative 8. So the positive negative 8 are the roots of the quadratic equation x squared is equal to 64.
The expression ax squared plus bx plus c is a perfect square trinomial if a and c are perfect squares and b is equal to twice the square root, the product of square root of a and c. So let's go to illustrated examples. Let's say we have 6x plus 5 equals 0. So, in here, a is equal to 1, b is equal to negative 6, c is equal to 5. So, to get the standard form, we transpose c or the constant term into the right side. So it becomes negative 5. The left side, a perfect square trinomial, we need to get the constant value. So to get the constant value, we need to get the half of the coefficient of x. So it becomes negative 3, then square. So it becomes negative 3, and then square. Square root of negative 3 is equal to 9. So your perfect square trinomial now is x squared minus 6x plus 9. Then, since you got the constant value, you to make it equal, you have to add the constant value to the other side to make it equal. So therefore, you have this equation. You must factor the left side. It becomes. Then apply the square root property. This root is 5, and the other root is.
Learn the fourth way of solving the quadratic equation using the quadratic formula. The quadratic equation can be derived using the concept of completing the squares from the standard form ax squared plus bx plus c is equal to 0. And it becomes x is equal to negative b positive negative square root of b squared minus 4ac over 2a. Now, let's solve it.
After learning the four ways of solving the quadratic equations, we need to determine now their natures. To get the nature of the roots, we have to get the discriminant by using the expression of b squared minus 4ac from the quadratic formula. If b squared minus 4ac is equal to 0, then the roots are real, rational, and equal. So let's try this example. A is equal to 1, B is equal to 4, C is equal to 1. So using the formula, substitute. Then substitute. For the nature of the roots are real, rational, and equal. If b squared is equal to minus 4ac is greater than 0 and is perfect square, then the roots are real, rational, and unequal. Example. In here, a is equal to 3, negative 1, c is equal to negative 2. So, apply the formula. Since the discriminant is greater than 0 and it's perfect square, then the nature of its roots are real, rational, and unequal.
If b squared minus 4ac is greater than 0 and not a perfect square, then the roots are real, irrational, and unequal. Now, let's get the nature of the roots of the quadratic equation x squared minus 6x plus 7 is equal to 0. Since b is greater than 0 and not a perfect square, then the roots are real, irrational, and unequal. The fourth nature of the roots is if b squared minus 4ac is less than 0, then the roots of it are not real or imaginary. If b is less than 0, then the roots of it are not real or imaginary.
Now, let's proceed to the sum and product of the roots of quadratic equation. There are other relationships that can be observed between the coefficient and the roots of quadratic equation. X of 1 equals negative b plus square root of b squared minus 4ac over 2a. The other root is negative b minus square root of b squared minus 4ac over 2a. The roots x of 1 plus x of 2. Then it will become and now let's continue with the products of x of 1 and x of 2. X of 1 times x of 2 equals negative b plus it will become x of 1 times x of 2 equals negative b squared minus the quantity square root of b squared minus 4ac quantity squared over 4a squared. X of 1 times x of 2 equals 4ac over 4a squared. It will become c over a. Products of the roots is c over a. Let's get the sum and the product of the quadratic equation 2x squared plus 3x minus 1 equals 0. A equals negative 3 over 2. Product x of 1 over 2.
Action.
What should we do?
I'm
bored. Aha! What about we
Play a game!
But what game? What about pass and catch?
Oh, that's great.
Game! Wait! How can we apply quadratic equation?
A ball is thrown from 3 meters above the ground with a velocity of 14 meters per second. When does it hit the ground? We can use quadratic equation in this situation, which h equals 3 plus 14t minus 5t squared, where h is height and t is time. $14t minus 5t squared equals 0, which is a quadratic equation. Standard form, it looks like negative 5t squared plus 14t plus 3 equals 0. Let us solve it. 5t times quantity t minus 3 plus 1 times quantity t minus 3 equals 0. Common factor is quantity t minus 3. Quantity 5t plus 1 times quantity t minus 3 equals 0. And the two solutions are 5t plus 1 equals 0 or t minus 3 equals 0. T equals negative 0.2 or t equals 3. T equals negative 0.2 is a negative time. Impossible in our case. That's why t equals 3 is the answer.
So as you can see, we can apply the quadratic equation in real life. Thank you for watching!
We are the Group 4 from 9 Curie. Bye-bye!